In this presentation, we're looking to use a recurrence relation to generate and analyze a geometric sequence. Yep. So recall from the previous presentation that the nth term can be found using this formula of Tn equals your first term, a, times your ratio, r to the power of n minus 1. So that's a formula we've already done. So the recurrence relationship describes the relationship between two successive terms. Hence, the nth term can be calculated by using the recurrence relationship given by this. So the first term is a, and then each subsequent term is r times the previous term. So that's our recurrence relationship. For example, generate and graph the first 5 terms of the sequence defined by the recurrence relationship, where term 1 is 5 and term n plus 1 is 2 times term n. Basically what this is saying is that each subsequent term is 2 times the previous term. So to find each term, we literally actually just do that. So term 1 is 5, term 2 is 10, term 3 is 20, term 4 is 40, and you could keep going with that as well. We're then asked to graph it, and I haven't actually graphed it in this example, but you would be graphing double the distance every time. So you would have a 5, then a 10, then a 20, then a 40, etc. So graphing it as a double. Part B says use a rule to calculate the value of the 10th term in the sequence. So when it says use a rule, that's when we're going back to that Tn equals a times r to the power of n minus 1 rule. In order to use that, you need to know what your first term is and what your ratio is, which you can read off your recurrence relationship. So to term 1, first term a is 5 and ratio is the 2, which gives us a general rule of term n equals 5 by 2 to the power of n minus 1. We're after the 10th term, so n equals 10, substitute it into our general rule, and we get 5 times 2 to the power of n, 9. This is what we put into our calculator, getting out a result of 2,560. Another application example of this is this volume situation. So the volume of a cube of cube 1 is 8 centimeters cubed, and each successive volume is 1.5 times larger than the previous volume. We're saying that Vn is the volume in centimeters cubed of the nth term in this sequence of cubes. The recurrence relationship that describes this is given by V1 equals 8 centimeters cubed and Vn plus 1 equals 1.5 Vn. We are asked to use the recurrence relationship, use this to generate the volume of the first 4 cubes in this sequence, and use these volumes to construct a table showing the cube number and then the volume. Because we're asked to use that recurrence relationship, you do need to. So 1.5 times 8, 1.5 times 12, 1.5 times 18 to get those values and put them into a table. Part B, use the table to graph it. So this is a sketch sort of graph. You do need to be aware of that. So I believe from memory I am going up in... So it would be 8, 12, 8, 12, etc., etc. I can't actually honestly remember. But yeah, graphing and put some scale and label on yours. Mine doesn't have it, which it should. And then describe it. So increasing relationship is enough to describe that. So use the rule for the nth term for this sequence to predict the volume of the 10th cube in this sequence. So to do this, we need to know our first term and our ratio. So a equals 8, r equals 1.5, which means that the general term or the rule for this nth term is Vn equals 8 times 1.5 n to the power of n minus 1. Note, I'm not using Tn. I'm using Vn because that is what the question gave me. Substituting in n equals 10, I get that the volume is equal to 8 times 1.5 to the power of 9, which I can put into my calculator and get out a result of 307.5469 centimeters cubed. That does need to have units attached to it because the question has units attached to it. And that would be my end answer.